Keniquel and I am an elementary math and science teacher development specialist. And today I'm here to present to you your math lesson. So before we get started with our math lesson, I want to make sure you have everything you need. So make sure that you have some paper, it can be any kind of paper, some paper, pencils, or some markers, anything that you can use to write with, any kind of combination. But we do want you to be able to write, have something to write on, and have something to write with. And if you have some graph paper, go ahead and get some graph paper because today's lesson is going to be over area and perimeter. And we're going to do a little math practice with some multiplication and a little math warm-up where we get to explain some of our thinking. Okay? All right, so we're about to go ahead and get started. And for today, for our warm-up, we're going to warm up of our math brain, and we're going to do this activity called Which One Doesn't Belong? And so which one doesn't belong is one of those activities or that strategy to where you're able to explain your thinking. And what they do is they give you a couple of models or images, and they want you to look at the images holistically as a whole. And then they want you to figure out which one of these images or models doesn't fit with the other three models in the category or the other models in the picture. So what I want us to do is we're going to do that today. Okay? So first, before we get started, we have some models here. We have a total of 4 models. And what I'm going to do is I'm going to explain each model to you. And as I explain those models to you, what I want you to do is I want you to start thinking about, which one of these models don't belong with the other 3 models? Okay? And remember, the one thing about this activity is that it's all about explaining your thinking. And so that means that it could be any answer. There's not one right answer. So one thing I want you to do is as you notice something, you notice, oh my gosh, that's it. That doesn't belong. Write it on your paper and go ahead and put your explanation as to why you feel it doesn't belong. And at the end of this activity, we're gonna see if we come up with the same things. All right? Okay, so let's get started. So we have 4 models here, and all of these models I noticed all have some rows and columns. And so I'm gonna start with the first one. The first model in this first box is going to be the red model. And I noticed that it has 4 rows, 1, 2, 3, 4, and 4 columns, 1, 2, 3, 4. Okay? So that's the first model. So now I'm gonna go to the green model. In my green model, I noticed that there are 1, 2, 3, 4, 5 rows, and there are only 3 columns. Okay, so there's 5 rows and 3 columns with the green model. So let's look at our blue model. Our blue model, we have, there's more rows. 1, 2, 3, 4, 5, 6. So there's 6 rows on the blue model, and there's 4 columns. 6 rows and 4 columns. And then we have our orange model. That last model, there's only 1 row, but there's a total of 6 columns. And so what I want you to do is I want you to think about it. And now remember, you jotted down some things, and I'm gonna go through my thinking. And I'm gonna actually write it down at the bottom, and I'm gonna list what my favorite one is that I noticed. And so as I was looking at it, I noticed that the red model, I noticed that this red model has 4 rows and 4 columns, but it's the only one that is the shape of a square. The other 3 cannot be squares. So I am going to put the red model is the one that don't belong because this is the only model that forms a square. I also noticed that it's the only model that has the length and the width as the same thing, which makes it a square. So the length and width are the same. That's my favorite one. I don't know if it's because it just stood out to me, but that was my favorite one. But there's some other ones. You could have said, the orange model. And you could have said the orange model because the orange model is the only model that has one row. So you notice that the orange model has one row only, whereas the other ones have more than one row. So that's another one. Let's look. What about the blue model? And I could look at the blue model and I could say, well, to me, the blue model is the only model that has an area more than 20 square units. So the blue model, only one that has an area more than 20 square units. There's one model left. What about the green model? And if I look at the green model, and I notice that it has 5 rows and 3 columns. That's the only one that has the length and the width are both odd numbers. So my green model is the only one that has the length and width odd measurement. And so because I know that that's the only one to have the length and the width as an odd measurement, that means my area is also going to be odd. So one thing I noticed about the which one doesn't belong is that it has so many different answers. And the one thing, as long as we were able to explain our thinking, we were able to do our work. And so when it comes to math and justifying our thinking and explaining our reasoning behind things, it all comes down to being able to explain our thinking, because one thing we notice is that we all see things differently. And so sometimes what I see that doesn't belong, you could have saw something different. And maybe some of you at home already have some different ones on here. So this one is which one doesn't belong. And remember, you can get this with any type of figures. We can have pictures, we can have models. So remember, just numbers. So just remember that this helps us just warm up our brain and get our brain thinking mathematically about which one doesn't belong and explaining our reasoning. And so now that we're all warmed up, we have our thinking caps on, we're ready to do some work. So we're gonna go ahead and just jump into our lesson. And if you notice, we dealt with figures today, which is gonna tie in to our lesson today about area and perimeter. But before we get started, we want to do a little skills. So today we're going to go ahead and move into our multiplication practice, which is our math skill practice for today. And one thing I know about multiplication is that in the past we have learned to represent multiplication using models. We have learned our multiplication facts, the basic facts. And so now today we're going to actually use those skills, but we're going to apply it to partial products. That's the strategy for today. And partial products is a strategy where you decompose multi-digit numbers or factors, multi-digit factors by place value to use to solve multiplication problems using basic facts. Okay, so today we're actually going to solve the problem 27 times 4. And so the first thing we want to do is when we multiply 27 times 4, we want to go ahead and write it at the top of our paper. Put a rectangle somewhere in the middle of the paper with some space so that way we have room to decompose our multi-digit number. So today our multi-digit number is 27. And so we're going to first decompose 27 by place value. And so when I look at the number, I know 27 consists of 2 10s and 7 1s. And so when I decompose 27 into 2 10s and 7 1s, I know that 2 10s is the same or has the same value as 20. And I know that 7 1s is the same value as 7. So now I have 20 plus 7, which is the same as 27. And so then we have our factor 4. And so what I want to do is I want to now take my decomposed factor and I want to use my box to help organize my thinking. And so I noticed that I have 2 place values, the tens place and the ones place. So I'm going to decompose my rectangle so that way I can have 2 place values. So I'm going to go ahead and draw a vertical line so that way I can decompose and separate it into my box. And so where I put my vertical line, I'm going to place the plus sign directly over it so that way I can also see where my thinking is going. And so for my first decomposed value, I have 20. And then I have plus 7 1s. And so on the outside of my partial product box, I am going to actually put the number 4, which is the other factor in my problem. So now I have 20 plus 7 times 4, which is the same as 27 times 4. We just decomposed it. And so just so that way I can remember, I'm going to put a little multiplication symbol in the corner so that way I can remember it. And so now I have 4 times 20. And because I remember I decomposed this 20 to 2 10s, I know that 2 10s times 4 gives me 8 10s. And 8 10s is the same as 80. So I'm going to put, just so I can remember, 2 10s times 4, which is giving me 8 10s. So that way I know that my value is 80. And now I'm going to go to my next partial box. And so now I have 4 times 7. 4 times 7, which is 7 1s, is going to give me 28. So now I have my 2 partials. And so now what I want to do is I want to add my partial products together to where I have 80 plus 28. And so I know that 80 plus 28 is the same as 108. So now I know that 27 times 4 is the same as 108. So what we did today is we multiplied a multi-digit number times a single-digit number, and we came up with our answer. And we used partial products as our strategy for today's focus. And so what I want you to do is I want you to hold on to your practice paper because we're going to use it later on today in our lesson. okay? All right, so now this is where we get into our next part of our lesson. So for today's lesson, we are going to actually review area and perimeter. Yay! And because we've been working on multiplication, we looked at our which one doesn't belong, and we noticed that we dealt with some area and some perimeter questions. We looked at figures or models that were in the shape of some rectangles. And so before we start our lesson, I want us to focus on, let's just do a quick review on area, okay? So let's look at area and perimeter. And so you notice in my picture, I have this big rectangle, and in the center, I wrote area. And along the outside of my figure, I have the word perimeter. And this is just reviewing those meanings of area and perimeter that you've learned in the past. Okay, so looking at perimeter, I noticed that that definition of it is the distance around a figure. So when I'm trying to find a perimeter, I want to go around my figure to find out what is my perimeter. And so when I look at the formula or what's on my mathematics reference chart, it's going to give me that the P, which stands for perimeter, equals the length plus the width plus the width. That's the distance around the figure. We have the length, we have width, and so that's how we get that formula. But when I look at it here, I notice I have two lengths. So repeated addition is the same as multiplication. So instead of adding all of them, I can also just say, I'm gonna take 2 and multiply it by my length. And then I have 2 widths. I can take 2 and multiply by my width and add those together. And that will also give me my perimeter. And if you notice, I wrote my length using the cursive letter L because I didn't want to confuse it with the number 1. So this is our formula for perimeter. And then we have the area. And if you look at the formula for area, it says the definition for area is the number of square units needed to cover the region. So that's us covering the inside of the region. So we look at our model here. We have our region, and I shaded it the pink color to match our area because this is the area. It's the covered area in our figure. And because I remember when I learned multiplication, I learned about the area model. That is going to bring me to the understanding of area, which is the length times my width. And so here, my area model will help me understand that the formula for area is length times width. And I have this here, and I just wanted to bring the anchor chart out so that way we can remember it, because we're going to come back and do the activities, and I want you to be able to use this information for your lesson. And so what I'm going to do is I'm going to actually take the anchor chart down, and I am going to just put a little reminder up for us, and I'll put it right here in the middle of the wall or somewhere on the board so that way we can remember. That's the perimeter. And we have another perimeter, because remember there's 2 different ways. So you can do it with the multiplication, or you can do the perimeter using addition, where you add your length plus your length plus your width plus your width. And then we also have the other formula, which is the area. And our area is our length times our width. So I wanted to make sure that we still had everything, and so that way we're ready for today's learning. So on today's learning, we're going to do a little activity where we get to practice area and perimeter. And so I want you to have some playing cards. And if you don't have any playing cards, that's okay. Just take a sheet of paper and tear it into pieces or fold it into pieces to where you can write the digits 0 through 9 on them. And go ahead and place them face down. And I'm just going to use a deck of cards because that's one of those things that's real easy to kind of pick up and go. And if you use a deck of cards, take out the face value, We don't want any faces in the deck. We only want to use the digits. And also take out the tens because we want single digits. Now you can leave the ace in there because the ace can represent the value of 1 or whatever value you want to give it. Today's purpose, we're going to let the ace represent the value of 1. Okay, so today we're going to actually find the area and perimeter using digit cards or playing cards in this case by creating rectangles. So the first step is we're going to pull 3 cards. Remember, they're face down. You're going to pull 3 cards. I have my 3 cards. And what I want you to do is I want you to take those 3 cards and I want you to place them on your paper. And you don't have to draw the boxes for card 1, card 2, card 3. You can just place the cards in order. So I'm going to place my first card there. My second card is going to be placed next to it. And then my third card is going to be placed next to it, where it says card 3. And so what I did was I just created a 2-digit number by a 1-digit number. So using card 1 and card 2, I created that and made it a 2-digit number. And that number is going to represent 12. Because remember earlier I said wherever you see an ace for today, it's going to represent the value of 1. So that's a 1 and a 2. And when we take those digits 1 and 2 and we want them to create a 2-digit number, we're going to make that value of this 12. And so that will be the value that will go inside of my table. And the next card will be our single digit, which is 7. So our 2 digits are going to represent our length. So our length is going to be 12. So on my table, I'm going to write 12. And my width is going to be 7. So for width, I'm going to write the number 7. And so now I have my length and my width. But now I want to actually create my rectangle. So this is where that graph paper comes in handy. And if you don't have it, that's okay. We still can create our rectangles using regular paper. So our length is 12. And so what I'm going to do is I'm going to start here and I'm going to make sure I have a length of 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now there's my length of 12. I want to make sure I remember that, so I'm going to label it. And I'm going to label it by putting the cursive letter L, and I'm going to say equals 12 units. Okay? And remember, the cursive letter L represents length because I didn't want to put a 1 to kind of confuse us. So the L is for length. And then we have, if you look at our table, the width is a 7. So now I'm going to do our width. And so I'm going to start at the corner and I'm just going to go down for 7. 1, 2, 3, 4, 5, 6, 7. And drawing straight lines can be difficult on a wall. And so here's our width. And I'm going to label it width equals 7 units. Okay, so we're almost there. The next thing is that I want to actually create a rectangle. And because I know the definition of rectangle means the opposite sides are the same, I know that if this top value is 12 units, that means my length at the bottom is going to also be 12 units. And I'm going to label it. Length equals 12 units. And then I'm going to do my width. If this width is 7 units, that means this width is also going to be 7 units. All right. So now we have our rectangle created. The next thing in our table says perimeter. And so I'm going to find my perimeter. So I remember that perimeter is the distance around the figure. And so this case, the rectangle, the distance around the rectangle. And so looking at my formula, I am actually going to use this one in the middle. Perimeter equals length plus width plus width. So I'm going to put P for perimeter equals 12 plus 12 plus 7 plus 7. So I know that is one way. But I also know I can write it using this formula. And underneath it, I'm just going to, or actually right next to it, I'm going to write that formula. Perimeter equals 2 times the length, which is 12, plus 2 times my width, which is 7. And I'm going to put parentheses so that way I can remember that this is my length and this is my width. Okay? So now let's go ahead and solve it. If I was to add my perimeter together, I have perimeter equals 12 plus 12 together gives me 24, plus 7 plus 7, remember our doubles, equals 14. So my perimeter will equal 38. And now I gotta put my label, which is 38 units. And so the same thing over here. Perimeter equals 2 times 12 gives us 24, plus 2 times 7, which gives us 14. So my perimeter is equal to 38 units. Okay, so there, our perimeter is done. I can go back to my table, and where I see perimeter, I'm going to write, make that look a little better, 38 units. So now I'm ready to find my area. Looking at the formula for my area is length times width. So now this is if I wanted to cover the rectangle. Remember, that's the area. Area means covering the region. How many of these little square units does it take to cover this entire rectangle? And so instead of counting each one, there's a faster way, and that's using a formula where we could do length times width. So for my formula, I'm going to put area equals my length times my width. And so now I'm just going to plug in the numbers that I have. Area equals length, which is 12 units. Times my width, which is 7 units. And if you know your 12s and you got it and you really understand it, then you can just go ahead and just work on your multiplication facts. But for those that we want to just practice our partial products, we're going to use it for this problem. And so we have 12 times 7. And so in this space right here, I'm going to multiply using partial products 12 times 7. And remember, our first task is to, I'm going to draw my rectangle, is to decompose 12. And remember, I look at my place value, and in my place value, I know I have 110, which is the same as 10, plus 2 ones. Okay? So now that we have our multi-digit factor decomposed, now I can actually put it in my partial product box. And I'm going to move this line down so that way we can actually have some room. And so I have 2 place values, so I need to make sure I have 2 sections in my partial product box. And so now I have to place my plus sign over to match my line and go ahead and place my place values there. So I have 10 plus 2, and we're going to place our 7 on the outside of our box. So then I'm going to put my little multiplication symbol there so I won't forget what I'm doing. So now I have 7 times 110, which is the same as 7 times 10 is 70. And then 7 times 2, which is 14. And now that I have my 2 partial products, I am going to add them together to create the sum of 70 plus 14, which is the same as 84. So now if we come back to my area, 12 units times 7 units is the same as 84 square units. So my area is equal to 84 square units. Okay? So in my table where it says area, I'm going to put 84 square units. Okay, so how did you like that activity? All right, so now if you notice on our chart we have some extra spaces. I want to make sure that you as well have an opportunity to practice. But before we practice, I want to give you a sentence stem that I want you to use to help understand and explain your thinking. And so in our sentence stem, we're going to say this. And remember, we built a rectangle, so a rectangle with the length of, blank, and our length was 12 units. So I'm going to put 12 units. And the width of units has the perimeter of 38 units. And the area of 84 square units. So make sure that you kind of get a chance to write down that sentence stem. I want to make sure that you practice using those vocabulary words and explaining your reasoning when it comes to finding the area and perimeter using the length and the width. And remember, you have some extra boxes here because I want you to be able to practice on your own. So go ahead and take a picture of this sentence because I want you to be able to have the sentence stem for later. But here's your practice. I created 3 cards. I already pulled them for you. So that way you don't even have to worry about it. And what I want you to do is I want you to practice on your own. Here are your cards. Card 1 and card 2. Remember the first 2 cards, digit cards, we're going to create a 2-digit number and it's going to represent our length. And then this single digit card will represent our width. And just so that way you can remember it, I'm going to put a little label This is going to represent your length. And this will represent your width. So I hope you enjoyed our lesson on area and perimeter today. I hope you remember some of the practices and the strategies we use. And I want you to be able to use them with your practice for tonight or for later today. So enjoy. Thank you for visiting with me. And remember to visit our HoustonISD.org at homepage for more resources. Thank you.